This lesson we are talking about true bearings. Okay, true bearings are measured clockwise from north, so we're going to have a look at our compass to start with, and then we're going to apply our trigonometry skills in order to help us out with some navigation. So true bearings are written a bit differently to what we're used to. They're written in 3 digits. So if we have a look at northeast up here, we are measuring from north, which is 0 degrees, all the way down to northeast, which is 45 degrees. So if we are writing that true bearing, we are doing 0, 4, 5 degrees, and it would have a T for true after it. All right, let's apply some of this information by using an example. Okay, so we are going to find where A is in relation to true north. So we know that we would have to travel this amount of distance angularly, and the information that we've been given is that it is 35 degrees back from east. Now we know that east is 90 degrees away from north, right? Here's our right angle. Then we know that south is 180 degrees, it is exactly opposite in this circle, and west is 270 degrees. So we can use that information to help us to find A. Now we know that A is 35 degrees away from 90, so we can literally go 90, take 35, it's going to give us 55 degrees. We want a true bearing which is written in 3 digits, so we will say that this is 055 degrees, T for true. All right, let's change it up this time. Let's go for B. We know that B is 45 degrees after E, which is at 90. So we can say B is equal to our 90 degrees plus the extra 45. So we've got 135 degrees. That's already in 3 digits, so we can simply write the T. Let's do C this time. We want to find out what C equals. C is 30 degrees shy of our west, which is 270. So if we went all the way around to west, it would be 270, but we're going to remove 30. So 270 subtract our 30 is equal to 240 degrees, and that is a true bearing. Now let's apply this to some navigation. So pause this for a second. Right, let's use our trigonometry. So we've got a word problem here. It says a ship travels due south for 3 kilometers. So as we do, let's draw ourselves a diagram. So 3 kilometers south, going to go straight down 3 kilometers. And then from this point, we are going to move on a bearing of 130. So we knew that if this is 90 degrees, right, here's our imaginary right angle, then we'll just remove this. Then our 130 degrees is approximately this way. Okay, it's between 180 this way and 90 that way, so this will do for now. We can put our jagged line back in and say, well, if this is 90 and we're going on a bearing of 130, this will be a 40 degree difference. All right, and we're going to travel at 5 kilometers there. So 3 this way, 5 that way, and there's our 40 degrees off our 90 degrees. So the question we are being asked, find how far east the ship is from its starting point. Now when we say east, we mean how far to the right has it moved, and we can actually now make a little right angled triangle out of this, and this is the information that we are trying to find. It has moved east this amount, so this is our unknown. So, as we do with all of our trigonometry, let's draw our triangle to start with. Okay, there's our triangle. We've got our right angle in here. We know this is our unknown. We know that this is 40 degrees and this is our 5 kilometers. So, what are we trying to find here? What kind of side do we have? This is our hypotenuse. This is our adjacent. So, we would have to be using cos. Cos of theta is A on H. We can say cos of 40 is equal to, what have we got? Cos of 40 equals x on 5. We could rearrange that, or we could use nsolve to do that. I'm going to rearrange it today. Cos of 40 equals x. And I'm going to use my old school calculator to find what that is. So 5 times cos of 40 gives me 3.83, and we know we are working in kilometers. So that's the information I have, and I can now add that to my diagram. Instead of having x here, we can now replace it with 3.83 kilometres. All right. So let's now have a look at our second question, which says find how far south the ship is from its starting point. So really, if we just get rid of all of this, what we are now trying to do is find out how big this side is. So we're going to call it y. So we know that this side has now got a value to it. It is 3.83. We can now find this using a number of different ways. So let's go with, we've got our hypotenuse, that's fine, we'll keep that. And we also are trying to find this, which is the opposite side. So now we can say we are going to use sine of theta equals O on H. So substitute in sine of 40 equals, what's our O value? Y. What's our H value? 5. So once again, we are rearranging sine of 40, or you can use NSolve, which is totally fine. Ooh, I have managed to have a little bit of a computer having some technical difficulties, but we can finish this off. So what is 5 times sine of 40? We can bust out our calculators. 5 times sine of 40 equals 3.21. So we can actually put that in here. I've lost my pen, so we'll have to go messy. 3.21, and we know that that is in kilometers. All right, so even though my drawing is not very accurate, we can calculate those things if we can navigate, first of all, if we can navigate using our true bearings, and if we can then apply our trigonometry skills. Okay?